Hey guys, this is going to be a quiz review video. So we're going to go over adding, subtracting, multiplying, dividing rational expressions, and some of those complex fractions as well. So we're going to look at a little bit of everything because that's what's going to be on your first quiz for this unit. All right, but let's start off with just a nice, just basic simplifying problem to run through the basics again. So in this case, there is no operation between two rational expressions. We just have a single one that we're trying to simplify. So in this case, that means we need to factor and see what common factors appear in the numerator and denominator that can be canceled. So for each of these, it's going to be just a GCF. So for the numerator here, we could factor out a GCF of 6w cubed, which is going to leave us with 2w plus 5. And then in the denominator, we have a GCF of 8w that can be factored out, which leaves us with 2w plus 5 as well. So looking for common factors here, it's going to be that 2w plus 5. These are going to cancel. We're going to be left with 6w cubed over 8w, and then using our exponent rules, we can simplify this a little bit further. So 6 over 8 would reduce, okay, if you're thinking about just fractions here, would reduce to 3/4. The w cubed over w would result in a w squared in the numerator. And there we have it. So let's look at another one where we start looking into these operations. Now, this is multiplication of two rational expressions, and notice that we have only monomials. Okay, there's no binomials or trinomials, so there's no factoring to be done. With these ones, we're going to start by multiplying the numerators and denominators together, and then using our exponent rules to simplify what we're left with. So if we multiply these, we're going to get 96 a to the 4th, b to the 7th in our numerator. And then in our denominator, we're going to get 24 a to the 6th, b to the 4th. So now we're just using our exponent rules. So let's start by dividing 96 by 24. Okay, that's going to give us 4. And then if we divide the a's, we're going to get an a squared in the denominator. And when we divide the b's, we're going to get b cubed in the numerator. And there we have it. So let's look at one that requires some more factoring, because I think the hardest part of these is the actual factoring part. Now, we've done a lot of factoring this year, so if you remember all of your factoring, this is going to be a lot easier for you. So in each numerator and denominator here, we have a trinomial. Okay, they're all quadratic, so those are fairly easy to factor. If you want to use your x to factor, you can, but you don't have to. When I say use the x to factor, let's say if I'm factoring this, I would be looking for the two numbers that multiply to -6, which is that c value, and add to that b value of 1. So in this case, those two numbers would be a +3 and a -2. Okay, but a lot of you, when we were doing this, just did it in your head, so you don't have to do that. That's just really a way to organize your thoughts. So let's go back and let's do that factoring to each of these numerators and denominators and see what we end up with here. So we already factored that first numerator. We said it's x plus 3 times x minus 2. Okay, the denominator, we'd be looking for two numbers that multiply to -12 and add to -1. So that would be a -4 and a +3. And now we can move on to the other rational expression here. Okay, in the numerator, we need two numbers that multiply to -20 and add to +1. So that would be a +5 and a -4. And then in the denominator, we need two numbers that multiply to +4 and add to -4. So that's going to be 2 -2's. So at this point, everything is factored, and we're looking for those common factors that can cancel out. So I noticed that I have some x plus 3's that can cancel. I have x minus 4s that cancel, and I have x minus 2s that cancel. Now, what you want to be careful about here is I only have one x minus 2 in the numerator, so it's only going to cancel with one of the x minus 2s in the denominator, not both of them. So if we look at what's left, we only have x plus 5 in the numerator, and we only have x minus 2 in the denominator. Okay, those are not going to reduce or cancel out any further. Okay, those x's do not cancel. Okay, the reason that we can cancel all of these factors in the previous step is because the operation between all of these factors is multiplication. When I have a bunch of factors being multiplied together, I can cancel out common factors. Our answer here has no multiplication of factors left. Okay, x plus 5, okay, is still like one thing. X minus 2 is still one quantity as well. So we can't cancel out part of a quantity with part of another quantity. Okay, it just isn't allowed. We can only cancel when there's multiplication between these quantities, or these factors in this case. So let's look at division here. Okay, we also have some more complicated factoring. So the division problems really aren't that bad. We're always going to change a division problem to a multiplication problem. So let's go ahead and do that first and talk about the factoring here in a second. So if I go ahead and change this to a multiplication problem, I really have this. Times the reciprocal. So 4 minus 9m squared. I'm going to go ahead and rearrange that order so that it's in standard form, over 14m minus 7. So now we're just in the same boat that we were last time. Now what's trickier here is the factoring. This trinomial and this trinomial are going to be harder to factor because they don't have leading coefficients of 1. So I'm going to go over to the side here, and we're going to factor these out off to the side rather than inside of the problem, just to save ourselves writing a bunch of extra steps. So let's do the numerator first. When I have that leading coefficient of 2, it causes some issues because now, instead of finding two numbers that multiply to -5 and add to 9, which by the way is impossible, we really need to find two numbers that multiply to -10 and add to +9, which makes this doable now. Those two numbers would be a +10 and a -1. So this is how we use those numbers, remember. We're breaking this into a factoring by grouping problem. I still have my 2m squared, but that plus 9m is going to split into 10m minus 1m. The minus 5 that we started with is still there as well. So what this does is it gives us those four terms that we need for grouping. So I make my groups. Remember, it's always addition between. That's why I lump the negative in with the 1m. And then we factor a GCF out of both groups. So in the first group, that's going to be 2m, which leaves us with an m plus 5. The GCF of the second group is a -1, which leaves us with m plus 5. So my factored form is m plus 5 times 2m minus 1. Oops. Minus 1. So that is the factoring for that numerator. Let's go ahead and do the same thing for the denominator. So you can see why I'm doing this off to the side here. It takes up quite a bit of room. So we're going to be doing essentially the same thing for this problem, for this denominator here. We need to find really two numbers that multiply to -30. And add to +13. Okay, Now, I know that you're thinking like -10 and -3. I know that's what's popping into your head here, but really, since one of our numbers has to be positive and the other has to be negative, our two numbers are going to be +15 and -2. So let's go ahead and do this. We have 3m squared still, but remember our 13m is splitting into 15m minus 2m minus 10. We make our groups, put that plus sign in between, and then factor out our GCFs. So for the first group, the GCF is going to be a 3m, which leaves us with m plus 5. And the GCF of the second group is a -2, which leaves us again with m plus 5. So our factored form is m plus 5 times 3m minus 2. So let's go ahead and take these factored forms and substitute them back into our original expression here. Okay, so to rewrite this, we have m plus 5 times 2m minus 1 over m plus 5 times 3m minus 2. Okay, and let's try to factor these other numerators and denominators here. In the numerator, I noticed that we have a negative leading coefficient. So I'm going to factor a negative out, and when we do that, it reveals a difference of squares that we're going to be able to factor further in the next step. In the denominator, I have a GCF of 7 that can be factored out. So let's cancel some things here. I notice that we have m plus 5s that cancel. We also have a 2m minus 1 that cancels. So what's left? Our numerator here, we said is going to factor further since it's a difference of squares. So let's go ahead and do that. That's really going to give us a negative 3m plus 2 times 3m minus 2 over, and then in the denominator we have a 7 times 3m minus 2. So let's cancel those 3m minus 2's out. There's nothing else we can do, so that gives us our final answer, which would be negative 3m plus 2 over 7. And you could distribute that negative if you wanted to. You don't have to. I prefer to leave it like this, but if you want to distribute, you wouldn't be incorrect. All right, so that was a lot of work. That was a lot harder. They're not all going to be that challenging, but it is possible to have factoring like that. Okay, it does take some time. Do your work off to the side, keep it organized, substitute it back in before you start simplifying further. So let's look at another division problem. The one thing I want to point off right off the bat here is that anytime you're dividing by something that isn't a fraction, remember you can turn it into a fraction by just putting it over 1. Okay, so that's going to be helpful here. Now, I want to point out that we've got some of those nasty factoring problems again. Okay, on the left side, that numerator and denominator, we're going to need to factor just like we did last time. So let's make some space off to the side where we can do those. So we have 4p squared minus 7p minus 15. And we've got 2p squared plus 3p minus 27. All right, so for the numerator, we really need to find two numbers that multiply to -60 and add to -7. So that gives us, that would be -12 and +5. So now we really have 4p squared minus 12p plus 15, or I'm sorry, plus 5. This looks like a 15 over here. Did I say 15? I might have said 15. This is really a 5. So plus 5p minus 15. Ah, that's where the 15 came from. Okay. That's where I was getting confused. So here's what we've got. We've got our four terms. Let's factor by grouping now. So if we factor out our GCFs, let's see, it's going to be 4p, which would leave us with p minus 3. And let's see here, it would be just a 5, which leaves us again with p minus 3. So we get p minus 3 times 4p plus 5. So that's what the numerator factors into. For the denominator, we need to find two numbers that multiply to negative 54. And remember, I'm getting that by doing the first times the last, that a times the c value. And let's see, we need to add to the middle term, or the middle value b, which is 3 here. So let's see, that would be a negative 6 and a positive 9. So now we have 2p squared minus 6p plus 9p minus 27. Factor by grouping. And we get p minus 3 times 2p plus 9. So let's go ahead and substitute those back into the original expression. Oops. Make sure I copied that down right before we go on. All right, looks good. So now remember, this was a division problem, and we always change division problems to multiplication problems. Okay, we take the reciprocal, and that's what we multiply by. So that would just be 1 over 4p plus 5. And now we're looking for those common factors that can cancel. So p minus 3 cancels, the 4p plus 5 cancels, and that leaves us with all that's left. Okay, so our final answer would be 1 over 2p plus 9. Not as bad as the last one, but still a lot of factoring. So let's take a look at some addition, subtraction, because we've looked at multiplication and division so far. Now, with subtraction, or addition, I should say, you need a common denominator first. Now, we're lucky in this case because both of our expressions already have common denominators. So that means that we can combine these two rational expressions together by subtracting. Now, when we do that, remember that the denominators are going to stay exactly the same. The only things that are subtracting are the numerators. So 2k minus 3, and then we're going to like distribute that negative. So minus k and then plus 11. Let's combine like terms in the numerator. So we would get k plus 8. Okay, I notice the GCF in the denominator is a 3, and if we factor that out, we're left with a k plus 8, which we could cancel with the k plus 8 in the numerator. Now, that doesn't mean there's a 0 in the numerator. That means there's a 1 in the numerator. So our answer is 1/3. Okay, here's an example of an addition problem where there are not common denominators. So what we need to figure out is, do these denominators have anything in common? Do they have any factors in common? So I am going to factor this denominator to see what it has in common with this one over here. So let's do that off to the side. Okay, 3m squared minus 14m minus 5. So two numbers that would multiply to negative 15 and add to negative 14 would be a negative 15 and a positive 1. So let's see here. If we factor by grouping, we're going to get m minus 5 times 3m plus 1. So let's rewrite this expression here so that we can see what they have in common. Okay, I'm just going to write it below this here. So we have m minus 5 times 3m plus 1. So now we can see that both of the denominators have that 3m plus 1 in common, but the left side is missing the m minus 5. So that just means that we're going to multiply that left expression by m minus 5 on the top and the bottom. Okay, so when we do that, in the numerator we would FOIL to get 2m minus 10. In the denominator, we're not gonna FOIL those. We're just going to put the factors next to each other. And at this point, we can see that we have the common denominators, and our next step is going to be to just add the numerators together for this problem. And remember, when we add, the denominators aren't being added together, okay? The common denominators are what allow us to add the numerators together. The denominator will remain the same, but those numerators are going to combine and give us 21m plus 7. Okay, that numerator has a GCF of 7 that could be factored out, leaving us with 3m plus 1. So since I have a 3m plus 1 in my denominator, that means I can cancel those out, giving me my final answer of 7 over m minus 5. Now, it is possible for these kind of problems that there is nothing in common between the denominators. So this would be a good example of that. On the left, we have n minus 6. On the right, we have n plus 1. Neither one of these is similar. Yes, they both have n's, but they don't have a common factor. So that just means that they need multiplied by each other. The left side needs multiplied by n plus 1. And that right side needs multiplied by n minus 6. So if we do this, we would get 3n, oop, wrong letter, let's try that again. 3n plus 3 over n plus 1 times n minus 6 minus 3n minus 18 over n plus 1 times n minus 6. So now I have that common denominator I needed, and we can go ahead and combine these by subtraction this time. So think about it as distributing that negative. We really have 3n plus 3 minus 3n plus 18. So let's combine our terms in the numerator. We would have the 3n's cancel, so just a 21 in the numerator. And we don't have any common factors, so that means that this is our final answer. Now, the only thing we haven't gone through yet are the complex fractions. So let's take a look at one of those. Okay, the first thing that you want to check is you want to make sure that is the rational expression in the numerator over a single denominator. So in this case it is. Okay, it's a single fraction. And is our denominator, again, a single fraction? We just want to make sure that if we had two separate fractions, adding or subtracting or multiplying, dividing in the numerator or denominator, we would want to make sure that we combine those together first before we proceed. So since we have a single fraction over a single fraction, what we want to do is we want to start by just rewriting this so it's a little more manageable, a little easier to look at and work with. This fraction bar is telling us that we really have w squared minus 1 over 8w minus 8 divided by w squared plus 6w plus 5 over 18w. And then from here, we've done these problems already. That means that we really just have w squared minus 1 over 8w minus 8 times 18w over w squared plus 6w plus 5. So we have changed this to a multiplication problem, something much easier to work with. So let's go through and factor all of our numerators and denominators now. Okay, the first numerator is the difference of squares. The denominator has a GCF of 8. 18w is a monomial, so no factoring there. And then that denominator is a trinomial, leading coefficient of 1, so super easy to factor. The two numbers that multiply to 5 and add to 6 would be 5 and 1. So there we go. Everything's factored. Now, looking for common factors to cancel, we have w minus 1s that cancel. We have w plus 1s that cancel. So let's rewrite what we have left. We've got an 18w over 8 times w plus 5. So the only thing I'm going to be able to do here is I'm going to be able to reduce this fraction to 9/4, making our final answer 9w over 4 times w plus 5. So anytime you have these complex fractions, the goal is really to turn it into a multiplication problem, which are much easier to work with. So let's do one last one. And this is a case where the numerator of this fraction is not a single fraction. We need to combine that together to make a single fraction before we move on. So I'm just going to do that off to the side here. Now, it's really not that hard. Okay, I need a common denominator. Right now, the denominator here is a 1, and then over here it's an r plus 2. So I really just need to multiply this by r plus 2. I'm try to squeeze it in here, which means I really have r plus 2 over r plus 2, which makes sense because anything divided by itself is 1, which was there to begin with, minus r over r plus 2. So if we actually subtract these, this simplifies to 2 over r plus 2. So let's substitute that back into the numerator here and rewrite this, making it a little bit easier for us here. So we really have 2 over r plus 2 over r squared over r plus 2. So now let's change it to a division problem. And now that we have it written as a division problem, we can rewrite it as a multiplication problem. Okay, and looking at it here, we can see those r plus 2s are going to cancel, leaving us with just 2 over r squared. All right, guys, I know the video is long, but truly, if you go through this video and if you attempted all these problems on your own, the quiz is going to be pretty straightforward. It's very similar to what we just went through. So reach out if you have any questions, and have a wonderful day.